Thank you all for joining in. Welcoming you all to this live machine learning classes. My name is Satyajit Pattnaik, and today we shall be getting into classification algorithms. Those of you who have joined this for the first time, just to let you know that we started this live machine learning classes yesterday. We started with the basics of machine learning, what is machine learning, the different types of machine learning, and we also had a brief understanding about few basic concepts. We also covered feature scaling yesterday, and we also covered the theoretical concepts of k nearest neighbors. Today we shall be getting more into the practicals of KNN, and then henceforth we will jump into various other algorithms. So let's wait for just 1 or 2 more minutes. People are still joining in. Yesterday, maybe it was the first class, because of which there were much more people than today. But we will try to wait for a couple of minutes so that people can join in. Thank you all who have joined so far. My voice is audible. Just give me a confirmation, yes, and then we'll proceed with the class. Yeah, voice is audible. So in the last class we talked about multiple topics, like what was machine learning, the basics of machine learning, the types of machine learning, like supervised, unsupervised, and reinforcement. And we also studied about k nearest neighbors, right? Those who missed it out, I won't be able to repeat it. Please go back to the last class and you can watch out the video. Today, if you are not aware of KNN, it's completely fine. We will jump into the practicals, and then after practicals, we will get into another algorithm. So you can start from there, and then you can go back and watch KNN later. Okay, so nothing to worry about. So KNN, just a brief idea about KNN, maybe in just 2 or 3 minutes. If you have different classes, let's say class 1, class 2, something like this, based on different features, if you have a new data point, you need to basically find the k nearest neighbors. That is what KNN algorithm is all about. And the nearest neighbors is based on the Euclidean distance concept. Basically, from this point, you have to calculate the distances, and then you have to define your k value, let's say 3 or 5. And let's say your k value is 5, you need to find the 5 nearest neighbors. Let's say this, and this. Now, as per the voting majority, this data point should belong to class 2. That is what KNN is all about. So let's jump into the use case practicals. So let me just write it down this way. Let's say ML classification. We will be using the breast cancer prediction dataset. Now, dataset link will be given to you. Maybe what you can do is just quickly go and search for this thing. Um, if you go and search breast cancer risk prediction, probably you will be able to find this link, or else I'll hold on for a second. Please type it out, github.com/, and you can follow. Type in, you will be redirected to this particular GitHub repository. Go to data. Okay, I'll hold for 2 seconds. Okay. um, okay, and then you should be able to download the data. Go to the data folder and just download this data.csv. Just go here and click on this download raw file. That's it. Okay, so this is what the file is all about. We have IDs, which is customer IDs. Yeah, from yesterday itself I'm just calling them customers. These are patient IDs. Okay, the use case is pretty simple. Again, just repeating, just for the sake of people who have not joined yesterday's class. This is a breast cancer prediction dataset. Now, the problem statement is very simple. Okay, uh, you have a list of patients who basically come to hospitals and go for blood tests and multiple other tests, and then they have all the information. What is their blood sugar level, what is their all the medical terms, what is their symmetric mean, what is their this, what is their that. So all these information are coming from different type of tests. Okay, whatever tests are done for breast cancer prediction, those kind of tests. And then the doctor basically tells whether the patient is having cancer or not. As simple as that. In this case, M means malignant, so you can call it as cancerous, and B means non cancerous. Okay, now you have this data. What you need to do is you need to train this data to a machine learning model. And once the machine learning model is trained, if a new patient comes in, she goes for a medical test, she receives all this information, and let's say the doctor is not there. So our machine learning model should be able to predict whether this patient is cancerous or non-cancerous. That is the problem statement. So this is a healthcare related data set. People coming from healthcare background, they will be able to relate it. Others enjoy it. Okay. So going back to the data set, this is the data set that we are going to use. So I'm just loading this file on Google Colab, and then I will quickly get started with the project. Sir, for machine learning project, do we should we do EDA or data pre-processing? See, data cleaning is a part of your machine learning modeling, but EDA is non-mandatory. If you want, you can do EDA. Okay, it is as a portfolio project when you are practicing. It is always good to perform EDA because EDA is done by data analysts, right? And we are currently going for machine learning. Machine learning models are built by data scientists or AI engineers, right? So that's why EDA is non-mandatory, but if you do, it's always good. Sonu, please wait. Okay, I'm just repeating once again. All your questions I will be picking during breaks. If your question is directly related to this model or whatever I'm teaching, I will immediately pause and answer. If the question is not related to what I am teaching right now, I will pick the questions during the break or post the class. Okay, let's start. Everybody has downloaded the file. You can also do the coding along with me. I'm going to go very slow. Okay, again, not too slow, because if I go too slow, we will be late. We have to complete this project or practicals in 30 minutes. Okay, so I'm importing all the libraries. See, writing codes, you don't have to be a pro in writing Python codes. So do not worry if you are not able to write codes by yourself. So no need to worry about it. Slowly, slowly you will learn. Just for the time being, try to understand the architecture, the flow. How am I building the model? I'm taking the data, and then what steps I'm following. Saida, for EDA, I have a dedicated 6 hours video on EDA. There, everything is explained for EDA, and last 1 hour or 2 hours, I have built a project. So you can go and watch it out. Or if you don't find it, just search EDA space Satyajit on YouTube, you will get it. I'm not that famous, so if you just search EDA, you will not get my videos. So just search EDA with Satyajit, you will get it. Okay, but watch it after this class. First focus on this class right now. Now I will be reading the file pd.read csv, and then I will copy this path and then I will paste it. That's it. I'll zoom in a bit so that no 125% is good. Okay. Now I will do a quick check on my data. Sir, I'm new here. Is this live session include complete classification project? It will be including a complete classification project with AWS deployment. Okay, but whatever I'm teaching right now, that is also a project. So don't deprioritize this. Samir, I will answer that question. So I'm giving a quick look at the data. Now, if I look at the data, I have taught you yesterday, all of these are my X variables or features. Okay, these are all my independent features, because based on these, the person will be detected as cancerous or non-cancerous. Okay, so these are all your X variables, and this is your Y variable. ID is a irrelevant column. We will be deleting them or dropping them as part of our data cleaning process. Okay. So the next thing is I will quickly go for a information df.info, and I will quickly have a check on the not null values. I don't see any null values, so I'm good. In case you have any null values in your own project, in your own data, you can always treat them. How do we treat them? Either you fill them using fill na, or you drop them using drop na. Okay. Now, in my case, there is no null values, but in case you have to drop it, how do we drop it? So simply you just use drop na, how equals to any, and then in place equals to true. In place equals to true basically is something where the changes will be directly applied in the data frame. So if you run this, your all the null values will be gone. But if you don't want to delete, you want to keep it and impute them using mean, median, or mode, you can use fill na. Okay, all these basic things are already taught in EDA, so please do not ask these very basic things. Okay, but even if you ask, I will be able to answer you, but it's recommended that you go for EDA videos, and then in the next Saturday class, I'm pretty much sure your doubts will be clarified. I mean, you will not have any doubts. My EDA video itself is very well explained. I'll quickly do a check on my data frame. I have 569 records. So I will be doing back and forth from Miro to my board, to my codes. So this is the data that I have. Okay. You can mention this project in your resume. No problem. Okay. So I have this data, right? How many records do I have? 569 records. Next, what I will do? I will be dividing the data into training and test. Training and test. Now, before dividing, I just want to do a check on my y variable. So, I will quickly do a check on my y variable. What is the distribution of diagnosis? Df dot diagnosis? No, diagnosis. Oh, nonsense. My bad. So df.diagnosis.value counts is giving me these many records. So for benign, we have 357. Benign means non-cancerous. M means cancerous. Okay. So what is my percentage? How do we find percentage? So let's say you have two numbers. Um, Person A has 8 chocolates. Person B has 6 chocolates. So how much percentage of the chocolates A has? Can somebody quickly tell me the mathematics? Okay, I'll zoom out. So total there are 14 chocolates. What is the percentage of chocolates A has? It is 8 divided by 14 into 100, right? And how much percentage B has? 6 divided by 14 into 100, right? So what I'm doing here is I'm taking the current count, and then I'm dividing with the total count, and then multiply it with 100. If I do that, you can see my cancerous patients are 37% and my non-cancerous are 62%. Okay. Now my next step is going to be creating my x and y variables. So splitting the data into x and y. So if I go back to the data, what is my x? My x is everything except these two. And what is my y? this one, right? So I will create my x from my df. So x is equals to df dot drop, and here I will drop two columns, id and diagnosis. And from which axis? From axis equals to 1. So my x becomes all the rows except id and diagnosis. Okay, so I'm deleting this. What is my y? My y is df dot diagnosis dot values. That is my y. So I divided the data into x and y. Okay, now what I will do here, I will do the training and test split. Why do we do training and test split? Training and test split is done because training data will be trained to the model and testing data will be used for testing how the model is performing, right? So here I will be using sklearn train test split. So if you don't remember the packages, it's completely fine. Just Google search, you will be able to get it. Okay. So from sklearn.model selection, import train test split. And then I will call xtrain, xtest, ytrain. See, coding is not that difficult. At least if you want to get started in the field of machine learning, literally it's not going to be a big task. Coding is simple. The only difficult part is the algorithms background, the statistical knowledge, the mathematical knowledge. And I'm here to help you out with that, right? KNN was taught to you from mathematics point of view. Similarly, decision tree, random forest, everything I will teach the mathematics behind it. That is more important. Coding though, you can easily just do a chat gpt and you will be able to write the codes. So it's not rocket science. Now here I will be calling my training and test split, and I will pass my x and y, and then I will be giving my test size equals to 0.25. Now in this line of code, what's happening is I'm dividing the data into 75 is to 25. Now what is the 75% of 569? If you do length of x train, you will see 426 records. So I go back to Miro. How many records? 426. And how many records in testing data? 143. Okay, I'm rubbing this part because we will be needing some space, right? Now my training and test split is done. Now what? If you remember the architecture, last class I told you the immediate step is feature scaling, right? Because different columns are in different format. However, like here it's in 100 format, this is in thousands format, this is in 0 point some decimal format, this is in tens format, right? If you directly pass this data, machine learning model will treat it like this: 17.8, 1001.8, 27.3, 0.08. So most likely it will prioritize the bigger numbers, right? That is why feature scaling is important. And yesterday I taught you, right? How many types of feature scaling are there? Can somebody tell me who is in the chat box? Okay, I'll wait for 2 minutes. Will standardization or normalization? That's great. So standardization or normalization. So standardization, there is a library, sklearn library. Inside that, we will be having standard scaler. Okay. Normalization, you can use min max scaler. Okay. Formula. Always, if you write down this formula 10 to 15 times, automatically your mind will, you will be able to remember it. X dash will be x minus x minimum divided by x maximum minus x minimum. This was the same question asked in yesterday's class. can we do feature scaling before splitting the data? I will explain you. Okay, we cannot. The reason I will explain. Yesterday also I explained. Today also I'll explain because it's a very very important interview question. Now, before we move on, can we have everybody to please like this video? Please hit the like button. I just see, honestly speaking, I'm not looking at the video right now, so I don't know how many likes do we have, but everybody who's watching this should like this video. Okay. Okay, I'll answer that question. Do not worry about it. Muhammad Bashir, very, very good question. So now I'll be going for feature scaling. Now, around feature scaling, there are multiple interview questions like, yes, the question that Bashir asked, feature scaling before splitting. Can we do it? Standardization or normalization, which is good, which is bad? Both these questions are already covered in yesterday's class. Okay. So let's say we will be going for standard scalar. So again, see, I'm just googling it out because I'm making it a habit for you. I remember all the libraries, but I'm making a habit for you how to get into the libraries. Okay. So just search sklearn standard scalar. You will be redirected to the code, to the documentation. Just copy this, and then from this import standard scalar. That's it. Now remember, make a make a note of it. I'm first calling the scalar. Okay. What is standard scalar? I'm just trying to do this. Okay. Now sc equals to standard scalar. Training sc is equals to sc dot fit transform. I will be passing my training data, and then test sc is equals to sc dot transform. I will be passing my testing data. Now notice this thing. What's happening here is, let me run this piece of code. What's happening here is, uh, what's happening here is I am calling the fit transform on training data, but only transform on testing data. Why? Because when you are going to create a model, when you are going to fit the model, you are going to train the model, you will be using training data for training purpose, right? Testing data, imagine testing data does not exist. Just imagine this data does not exist. These 143 records, they don't exist. Just imagine that way. Now, let's say records come one by one. The model will be predicting one by one, right? So you will not have the mean and standard deviation for testing data. So the idea behind this code is we use fit transform for training data because in this process we calculate the mu and sigma of training data. Based on that, we transform the data. And when we are doing test transformation, we use the same value for the testing data. Okay, so let's say my mu value here is, let's say, 14. So we will be using the same mu value while transforming the testing data. Okay, and that is one of the reasons we cannot do this step before the training and test split. If you do that before training and test split, that means you are transforming or standardizing or normalizing the entire data, which is wrong. Okay, so I'm doing this now. Once that is done, I will show you how my new data looks like, and you can see all of these data are scaled down. Similarly, you can also check your X test SC. They are also scaled down. Got it? So mu and sigma is based on the training data. Same in normalization also. The minimum, X minimum and X maximum, all data will be using the training data. Based on that, you will be transforming the testing data. Okay, that is the reason. Got it? Now my transformation is done, my feature scaling is done. So I will go back. What I'm doing here is I'm doing feature scaling, and then I'm having the new x train underscore sc and new x test underscore sc. I also have y test. I also have y train. Okay, y train, y test. What is your y train? Y train is your class label, right? Y variable. Done. After that, nothing. I mean, there are some feature engineering steps that we will be covering later, but right now, with whatever we have studied so far, we will be building a model. Okay. So we have studied KNN so far. So we will just Google sklearn KNN, and you can see you are redirected to the sklearn page. sklearn.neighbors has kneighbors classifier. From sklearn.neighbors, import k neighbors classifier. Done. Then the first step is initiate the class or the classifier. So I will write it down as model underscore knn, and then I will do k nearest neighbors classifier. Now here I'm just calling the classifier. Okay, try to um, be attentive here. Here I'm just passing the classifier. But if you go back to this code, can you see there are so many parameters? There is n neighbors, there is weights, there is algorithm, there is a leaf size, there is p, there is metric. So many things are there. Now, when you are directly calling like this, that means you are using the default parameters. And who created this default parameter? The creator of this algorithm, right? Default parameter is created based on certain criterias. Maybe this algorithm was tested on 100 or 200 sample data sets. Based on those sample data sets, maybe the best performing combination was this. That's why they made it default, right? If you want to change, you can change. Let's say I want to change my n neighbors to 7. So you can do like this. Now, your question might be coming, how to get the best value? Whether 5 is good, or 7 is good, or 9 is good, which one is good? How do we get to know that? That is where hyperparameter optimization will come. Again, that's an advanced topic that we will be covering later, not now. Once we go through that topic, we will again come back to this problem statement or a new problem statement, and we will show you how those steps are performed. Okay. Now, let's just blindly call the basic classifier. And then I will be passing the data to classifier. Now here the training happens, model knn dot fit. So I'm going to fit the training data into this model. The mathematical part is done by the library. Yes, Pranay. Standard scaler internally is doing this. X minus mu divided by sigma. Okay. Okay, done. So this piece of code is simple. I'm calling the classifier and I'm training the data into the model. So I will just draw the architecture. So I called my machine learning one model. Now this is a KNN model, and I'm passing the training data. Got it? I will run this. Now my model is ready. Now what I will do is I will only pass the testing data to the model for predictions. And then the model will be able to predict how many predictions? 143 predictions. And then I will take my y test data, and then I will compare this with this. Let's say there are 100 correct predictions. So your accuracy will be 100 divided by 143 multiplied with 100, whatever it will be, somewhere around 60-70%, 69%. Got it? So now I will pass the testing data to the model for predictions, and I will store, let's say I will call model underscore knn dot predict. I'll predict it on test data. Now I am going to store all the predictions in a variable called as ypred. Okay, let me write it down as ypred knn, because in the future we will be using other algorithms also. Okay, now predictions are done. If you can check, you can check. Ypred looks like this and your y test looks like this. Okay, so if I compare the first row, I think all the records it has predicted properly. Yeah, I mean, looks like it is doing a good job. Yeah, it is doing a good job. So mostly the algorithm is working well. Now what? Now I will be finding this thing. I'll be comparing and I'll be finding. Now how to compare and find? Here you will be using some classification metrics. So I will write it down as classification metrics to check how the model behaves. So there are multiple classification metrics: precision, recall, confusion metrics, everything I will be teaching. Do not worry. Right now, I'm just taking the example of accuracy. Okay. So from sklearn dot metrics import accuracy score, and then I will print accuracy score, and then here inside that I will pass my testing data, sorry, y test and my y pred underscore knn. If I run this, okay, double brackets, if I run this, maybe I'll just multiply it with 100, and then I will round it up to two decimals, so it's 95.8%. 95.8% accuracy is phenomenal. But again, this is a medical healthcare related data set, right? So healthcare related data sets, you have to deal very carefully, right? If somebody is actually having cancer, the model predicts them as non-cancerous. That is a very, very critical problem, right? So in healthcare industry, you have to deal with the use cases very carefully. I'll come back to this topic on how to deal with healthcare industries. There are some other metrics that we should focus on. But for now, with our limited knowledge on KNN, we are able to create a classifier. Now, what I will do is I will try to write down a simple piece of code, predict for a new patient. So, for a new patient, we will be doing the predictions. Let's say I'll pick one of these patients or maybe one of them, and I will only take the x variables, not the y variable, and then so here this is my information. Let's say I will just find and replace. I'll replace it with comma, replace all. So this is my entire data. Now I will take, let's say, new data. Let's say to bring on one page, this is how my data looks like. Okay, so we will change few readings, because this data is already a part of the model training data, right? So we will change something. Let's say there is a new patient that comes into the hospital. He or she, not he, it's a breast cancer prediction, she goes through different treatments and blood sugar tests and all those things. So we get the readings. Okay, so we will try to change the readings a little bit. Let's say we'll make it 22, we'll make it 16, we'll make it 121, and we'll change this to 1, we'll change this to 2, we'll change this to 3. So I'm completely randomly changing the values, right? Let's say 2, let's say 9, and so on, right? So I have randomly changed the values. So this exact thing was not a part of the model. Now what I will do is I'll pass this. Can I directly do the prediction on this data? What do you think? Let's say I got a new patient information. Can I directly get the predictions? No, right? You have to do the feature scaling transformations, and then only you can do the final this thing, right? So we will be doing the same thing. We will be taking the data, and then we will be creating the standardized values. I will call the transform function, and I will call the new data. Got it? Now if I look at my new data, these are my new data points, and now I will do the prediction. Let's say y pred single. Let's say I will call my model knn.predict new data. And what is my prediction? The prediction is the patient is non-cancerous. So pretty much sure there has been some information that we have tweaked, which made this person benign. Now I will directly take this data, exact the same data, and I will also test it on that. Let's say new data 1. Okay, new data 1, and now I will do the same thing, and then I will do the same thing. So new data 1 SC, new data 1 SC, new prediction single. I'm just changing the variable names, that's it. And you can see this patient is being predicted as malignant. And if you look at the record, this patient was malignant, right? So the model is reading well. The model is reading well. And again, this is a not very complex problem statement, but we are able to create a machine learning model, right? Is it possible to use normalization instead of standardization? Yes, you can use. Yesterday class I have explained this in depth, so go back to yesterday's class. If you are complete beginner, recommendation will be go through yesterday's class properly, explanation has been done. Okay, but yeah, arbitrarily you can choose normalization or standardization. Using either of them is completely fine, so it does not impact the model a lot. Value must be between 0 to 1 to be read by computer. No, values should be in a particular format. 0 to 1 is not mandatory, but it has to be scaled down, right? So yeah, because normalization brings you to a scale of 0 to 1, but standardization does not brings to a scale to 0 to 1. Okay, what do you mean another metric? You're talking about classification metrics, or you're talking about normalization, Gayatri? If you're talking about class, okay, I'll wait for your comment. Gayatri, are you talking about classification metrics to check precision, recall, and other things? Yeah, yeah. So that we will wait. We will wait till we cover decision tree, random forest, and SVM, and one more algorithm, and then we will jump into classification metrics. Because right now I'm only focusing on accuracy score. We have it covered. I will explain you confusion metrics, classification report, AUC, ROC, everything in depth. Don't worry. Again, for now, Sai, that's a good question. Which feature is most important? which feature is not, that comes under feature engineering. Right now we have just created a basic model. Feature engineering has not been taught as of now. Okay, we will cover that. Yeah, all the practical lessons will be created under my GitHub repository and I will pass it on to you. I can create it immediately, just in case you want to access the code on the go immediately, we can do that. So let me just quickly create a basic repository. Let's say ML classes. Uh, so just go to github.com/pik1989/ml classes. Okay, you will be able to get it. I'm downloading this and I'll upload it. I'll rename all these files later, but right now, immediately, if you want to download, you can download and check the code. Okay. So basic algorithm is done. Now I will move on to the next classification algorithm, which is going to be decision tree. How do we proceed with this? Now we will be explaining you decision tree, mathematics, and then again the practicals, random forest, mathematics, practicals, SVM, mathematics, practicals, and then once the basic algorithms are taught, then we will jump into feature engineering and other things. Okay. Uh, सर ये recorded sessions बनाया करो. See, some people are new. कुछ लोग स्ट्रीम में नए होते हैं, कुछ लोग they already know some knowledge, so I have to cater both the public, right? So you have to deal with it. So anyways, jumping into decision tree, one of the most crucial algorithms in the space of machine learning classification especially is decision tree. Decision tree works on the principle of identifying the root node and creates a tree to traverse from top to bottom approach to identify the right classes. Live is bekar or focus less on comments. Godel Shadow, you can leave the stream if you're not liking the stream. It's completely fine, but let me decide what to do. Okay. Thanks for your comment, by the way. Okay, so sorry, got diverted from the comments. Decision tree basically helps you to okay. This algorithm is used for classification and regression both, but with the context of classification, what happens is it helps you to create a decision tree, and based on the decision tree, you should be able to take a decision. Now, for example, many of you might I'll take a simple example. Let's say you are trying to get a new job. Okay, now for new job, for most of the people the most important feature is salary. See, for most, I'm again generalizing it. For some of you it could be brand. You can compromise on the salary, brand is more important, that's fine. I'm just generalizing. Most of the people, they focus on salary. Now imagine you are a fresher. Okay, I'm again taking the example of a Indian fresher. Okay, coming from a tier 3 college. Now you have some requirements. If my salary is less than 3 lakhs, definitely I will not take it. It's a no. I'm not interested in less than 3 lakhs. If my salary is 3 to 5 lakhs, and if it is in Bangalore, definitely I'm not taking it. If it is 3 to 5 lakhs but it is remote, probably I will take it. If the salary is greater than 5 lakhs, And if it is in Bangalore or Mumbai, I'm writing it as Bangalore and Mumbai, Bangalore and Mumbai, then again I'm not taking it, or else if it is remote, I'm taking it. So I'm what I'm trying to say is, in your head you basically create a decision tree, right, based on which you take a decision. So okay, this should be yes, my bad. So greater than 5 lakhs, you're okay to jump into Bangalore or Mumbai. Remote also, yes, you will jump in, right? Now there are different features when you are analyzing a particular problem statement like this. There are different features that goes in your head, and based on different features you prioritize. For me, salary is top, then comes location, then comes the type of company, whether it is a startup or a big company, and then I will take a decision, right? Decision tree is based on these principles. So the top node is called as a root node. Okay, and all the bottom nodes, the decision nodes, these are called as leaf nodes. All these are leaf nodes. Okay, our main task is to identify the root node. Okay, so if you are given a problem statement, let's say I'll talk again about the breast cancer prediction. You have different features, right? Based on different features, you should be able to identify which feature is sitting on top, which feature is most important, and then which feature is second most important. And that's how your tree will be built, and then you will be able to take the decisions, right? So the mathematical part inside decision tree, there is a parameter called as criterion. Okay, criterion is a hyper parameter in decision tree classifier. I'll just quickly open sklearn decision tree classifier. I understand, Godel. I can completely understand your concern, but the thing is, see, the beautiful, the best thing is people join all my classes regularly. As simple as that. So in that case, I can assume people who have already joined class one, they already know about class one and they are joining class two, so they already have knowledge on class one. But that is not the case on YouTube videos, right? In YouTube videos, there will be new public that basically starts learning from class two. They might not have attended class one, so they might be having some doubts. So I cannot help, so we have to cope up with that. So decision tree classifier um, has a parameter called as criterion. Now criterion has different options. The two most important options are Gini and entropy. Now based on these Gini and entropy, your model basically identifies the root node or the top most important feature. Okay, so we will be taking the example of either of them. Maybe we'll go for a Gini approach. Entropy approach, going through both of them will take a lot of time. Let's see. We'll first go for Gini approach, and then we will try to see how mathematically for a particular problem we are able to solve using decision tree classifier. Okay, so we have the same thing like yesterday's class. I have a notepad, I have a sheet. Decision tree classifier. Okay, now this is a very simple and classic example you will find in multiple blogs. Very easy to understand. That's why I have taken the example of the same thing. Now I will be taking this into Miro and I will be explaining you. Uh, let's say I will take the screenshot of this, and I will be directly explaining you this thing. Okay, now this is my data. Okay, Now using this data, what are my features? This is my features x1, x2 and x3, and this is my y variable, right? Our question is, given a particular condition, let's say the age is new, the competition is no, and the type is hardware, what should be the profit? Is it up or down? That is the question. So your y variable is profit or loss, and these three are your x variables. Our goal is to identify the root node. Okay, repeating once again, practicals is simple. Decision tree classifier, calling a decision tree classifier is just two lines of code, but understanding the mathematics is important. So pay attention. Okay, so first of all, the lower the Gini index, the more is the information. Okay, now how many ups and downs do we have? There are five downs and there are five ups. So first of all, I will create the Gini index of the sample data. So the formula is very simple. 1 minus pi by total square plus class 1 and then class 2. This is your class 1, this is your class 2. Now let's say you have 3 downs and 7 ups. In that case, this will be 3 by 10, this will be 7 by 10. Okay. So in this case, as this is 5 and 5, that's why it is like this. Then what will be the value? 1 minus 5 by 10 is 0.5 square, 0.25, and this is 0.25. So if you add them, it will be 0.5. So 1 minus 0.5 is 0.5. So the Gini value of the entire sample is basically 0.5. Let's say, let's say in your problem statement, there are four classes. Okay, let's say for class 1 you have 6 records, for class 2 you have 2 records, for class 1 you 3 you have 1 record, for class 4 you have 1 record. So what will be the Gini value here? The Gini value here will be 1 minus 6 by 10 square plus 2 by 10 square plus 1 by 10 square plus 1 by 10 square. I hope you are able to get my point. So this will be 36 plus 4, 40, 41, 42 by 100, which will be 0.58. Okay, ignore this. We will be majorly be focusing on this because this is related to this use case, right? Now the next step is individually I will be calculating the Gini index of all of these features. So I'm taking a little bit down till here. Let's say I'm just focusing on age. Okay, age has how many attributes? Old, new and mid. Three attributes. Out of old, how many profit up, how many profit down? There are three olds, all are down, right? So 3 down and 0 up. For new, how many up and how many down? New is here. 3 ups and 0 downs. For mid, how many up and how many down? 2 downs and 2 ups, right? 2 and 2. So for this one, individually, the Gini value will be is going to be 1 minus 3 by 3 square, which is going to be 0. Okay. For this one also, the Gini value will be basically the formula is 1 minus 3 by 3 square plus 0 by 3 square. So 0 by 3 is anyway 0, right? So 3 by 3 is 1, 1 minus 1 will be 0. And for this one, the Gini value will be, pause me if you have any doubts, okay? The Gini value will be 1 minus 2 by 4 square plus 2 by 4 square. This is 2 by 4 is 4 by 16, 4 by 16, 8 by 16. This will be 0.5. Okay. So individually, you have the Gini values of old, new, and mid. Okay. Now, now you have to calculate the weighted average. The weighted average of the age is, now what is the Gini value of old? It is 0. 0 multiplied with, how many old do we have? We have 3 old out of 10, plus Gini value of new is 0 multiplied with, how many new do we have? 3 divided by 10, plus what is the Gini value of mid? 0.5. How many mid values do we have? 4. 4 by 10. So it will be cancel, cancel. 4 by 10 is 0.4. 0.4 multiplied with 0.5 will be 0.2. Okay. So the Gini value of age, the final Gini score of age is 0.2. Till now, do you have any doubt? Which algorithm is powerful? You will come to know. Please attend all the classes. Automatically, you will come to know. Okay. Any questions so far? Till now, the overall Gini value we got. We got the final Gini value of age. Whoever is attending this class, recommendation will be use pen and paper and do the mathematics along with me. Calculated weighting average, because age has multiple attributes, right? So you will be, finally you will be doing the weighted average. Okay, because ultimately our goal is to calculate the Gini index of age. We are calculating the Gini values of each and every feature. Okay. Okay, going back to the second feature, which is competition. Competition. Competition, how many values do we have? We have yes and we have no. Inside yes, how many profit, how many down? Inside no, how many profit, how many down? For yes, 1 down, 2 down, 3 down, 1 up. 1 up, 3 down. For no, down, down, up, 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 up. So 4 up and 2 down. Okay, I'm explaining for competition. See if your doubt is clarified. The overall Gini index is clear. The overall Gini index is calculated based on the y variable. Okay, this is our final Gini index for the entire sample, right? And here individually for every feature we are calculating the Gini values. So yes has 4 records, no has 6 records. Out of these 4, profit is 1, uh, 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 not, I mean, loss is 3, and for no, 4 profit and 2 loss, right? So what will be the Gini of this? So I will write it down as Gini S. What will be the Gini of this? Can somebody tell me? It will be 1 minus 1 by 4 square plus 3 by 4 square, which will be 1 minus 3 square is 9, 9 1 10 by 16, which will be 6 by 16. 6 by 16 will be 3 by 8. 3 by 8 will be 0.32460 0.375. Okay, similarly for this, the Gini value will be 1 minus 4 by 6 square plus 2 by 6 square. The denominator, how is this coming? This is nothing but the total sum. Okay, this will be 1 minus Denominator is 36. Numerator is 4 square 16 plus 4, 20 by 36, which is 16 by 36. This will be 8 by 18 or 4 by 9. 4 by 9 is how much? 0.44, something like this. Okay. Okay. So Gini index of yes, Gini index of no. So what will be the weighted average of competition? The weighted average will be, how many yes do we have? 4, right? So 4 by 10 multiplied with 0.375 plus 6 by 10 multiplied with 0.44. What will be the value? The value will be zero point 0.4 multiplied with 0.375. It is 0.15. This is zero point 0.6 multiplied with 0.44, 0.264. So if I add, it will be around 0.414. Okay. Now, comparing age with competition, who has higher Gini value? Competition. Who has lower? Age. Okay. Now I'll go to the last one, which is going to be type. I'm doing it here. I don't have space. How many type do we have? Let me just take the screenshot here also, just in case you want to have a look at it directly. So how many type do we have? There are two types, software and hardware. How many software? One, two, three, four, five, six. Six software and four hardware. So out of software, how many profit, how many down? Out of hardware, how many profit, how many down? So software down, 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 three down, three up, three down, three up. So here also two down, two up. So here the Gini value will be 1 minus um, second 1 minus 3 by 6 square plus 3 by 6 square, which is 0.5, and this one also is going to be same 0.5. Okay, the Gini value is going to be 0.5, 0.5. What will be the weighted average of type? How many software? 6 software, right? 6 by 10 multiplied with zero point 0.5 plus 4 by 10 multiplied with zero point 0.5. The total is, this is 0 0.6, 0 0.3 plus 0.4 to 20, 0.2. So total is 0.5. Now, age, the final Gini value is 0.2. Competition, the final Gini value is 0.414, and for type the final Gini value is 0.5. Okay. If I go back to the beginning, what did I tell you? That the lower the Gini value, the more information you get. That means whoever has the lowest Gini value, that becomes the top priority or top feature. So in this case, my decision tree will look like this. I have age. And then what do we have? I don't know as of now. But age is confirmed. And as we have three ages, old, mid, and new. So definitely here will be old, here will be mid, here will be new. After that, how it will look, I don't know. After age, whether competition is better or this thing is better, you cannot take these numbers. You cannot take these numbers. These numbers are only like when you have done it on the entire data set, you just have to pick the lowest Gini, that becomes the most important feature. After that, whether this is important or this is important doesn't matter, because your tree is getting diverted into three different segments, right? Now, for old, you have to again take this information. So let's say For old, you will take only these three records. You will take only these three records and you will again do the same process. Now here you can ignore age because age is already done, right? Only with these records you have to find the Gini index of competition and type. Now how many yes do we have? We have one yes and two no. For type, we have two software and one hardware. For yes, do we have a profit or a loss? For yes, we have one loss and zero profit. For no, we have zero profit and two loss. For software, how much profit and how much loss? For hardware, how much profit and how much loss? So here, um, for software, we have three losses. For sorry, my bad. For software, we have two losses, and for hardware, there are one loss and zero, something like this. Now, in this case, you can see the Gini of this will be zero. The Gini of this will be zero. The Gini of this will be zero. The Gini of this will be zero, right? So in this case, only for age old, nobody is important. Why? Because you already have a closer here. If the person is the age is old, definitely the profit will be down. You can see. Similarly, for new, the profit there will be up. So there is a closure on these two leaf nodes. Now only this leaf node is pending. So you only have to take the next step for the mid records. Now I will only take the mid records and I will try to identify from the mid records which one is important. Only for my mid records, I will do the same step. Okay, competition, yes, no, type, software, and hardware. How many yes competition do we have? We have two yes and two no. How many software do we have? We have two software and two hardware. For yes, how much profit, how much loss? For yes, there are two losses and zero profit. For no, there are two profit and zero losses. For software, one loss and one profit and one down, and one profit and one down. So here the Gini will be 0, Gini will be 0. Here the Gini will be 0.5, right? If you calculate, you will be able to understand. Let's calculate. Gini of this is 1 minus 1 by 2 square plus 1 by 2 square, right? Which is 1 minus 1 by 2 square is 1 by 4, 1 by 4, 1 by 2, which is going to be 0.5. So the Gini of this is 0.5, the Gini of this is 0.5, right? And what will be the weighted average of type? The weighted average of type is 2 by 4 multiplied with 0.5 plus 2 by 4 multiplied with 0.5. This is 0.5, 0.5, 0.25, 0.5, 0.5, 0.25. So the total Gini is 0.5. And here, what will be the weighted average of competition? It will be 0, right? Now, which is lowest? Competition is lowest, right? So if I go back to my decision tree, here comes competition. Competition. Yes and no. Again, for yes and no, you have to again divide the data into yes and no for mid. Take only these two records, and then you can see yes and no, and then you can do type for software and then hardware, and this process goes on. Okay, so till second level we were able to identify age is the most important, and then you ignore the age, take the rest of the features, and then calculate which one is better, and then the process goes on. So when it comes to real time industry level problems, mathematically you cannot do this, because you will be having hundreds and hundreds of features, right? But practically, if you go and implement a decision tree classifier, automatically you will be able to understand internally how the calculations are happening and how the trees are getting created. You can, there are some visualization libraries like graphways and various other things, based on which you can also visualize your graph. Okay, so let's take a very short break, 5 minutes break, and we will be back. And then we will jump into the practicals of decision tree. In case, in the meanwhile, you have any questions, you can use the comment section and ask me. So, any questions so far? Okay, let me go through some of your comments. Yes, we are calculating kind of a mini index. Yes, not mini index, Gini index. Yes. Okay. Repeat classification metrics. I have not covered classification metrics yet. I have just covered accuracy score. Okay. So once we will jump into all the metrics, I will explain you everything in depth. Which algorithm is powerful? Yeah, this is something that it's based on experience, but classification algorithms or regression, there are ensemble learning algorithms like XGBoost and Ada Boost and Cat Boost. These kind of algorithms are, they perform way better as compared to traditional algorithms like decision tree, knife base, and all those things. Okay, but it depends. That's why we have to do a hit and trial on different algorithms. For sure, we can do that. The git link is okay. Um, Again, I just have randomly created the git, so I will beautify the git later. But for now, I'm just adding the link in the description of this video. Okay. Uh, okay, I have just added it in the very beginning itself. Just refresh the video, you will get it. Code is given. It's very simple, right? GitHub.com slash pik 1989 and then slash ml classes. Okay, let me take a genuine 2 minutes break. I'll be back and then we'll go ahead. Is this possible to use decision tree for regression? Yes, decision tree is used for regression and for classification both. um, Dealing with missing values, we only use fill na. We have to use fill na, but before that we have to check the data types are proper or not. I get error, the whole column is replaced by only one median. Why it happens? The whole column is replaced with one value, the whole column is replaced. No, that should not be the case. Check the code, or just copy that code into ChatGPT and ask ChatGPT will rectify the codes. For the decision tree algorithm, the mathematical calculation is always the same as explained like Gini. Yes. For categorical data, this is how the calculation happens. For numerical data, the calculation is little bit different, but almost same. Okay, I'll just take a 1 minute break, quickly come back, and then we'll get into the practicals. Now, entropy is little bit different. Entropy concept is little bit different. If you want, I can go through entropy based approach also. How much time do we have? We might not. Okay, let's see. So I'm back. Entropy based also. Let's do a simple explanation. Let's do it properly. If you are teaching, we should teach it properly, right? So entropy based. Now in Gini, what happens is if your Gini score is low, it is better. In entropy, if your entropy score is high, it is better. Both are two different techniques mathematically. Okay, so if I take the same example, let me take the same example. Where is my Excel sheet? Um, okay, now this is my same example, right? So how does the entropy system works? First of all, how many downs we have? We have 5 downs and 5 ups, right? What will be the probability of down? The probability of down is 0.5. The probability of up is 0.5, right? 5 out of 10, 0.5, right? The first thing that we do is we calculate the entropy of class attribute. So I will write it down as entropy of CA. The formula of entropy of CA is very simple: minus P divided by P plus N log P by P plus N minus N by P plus N log N by P plus N. Okay? What is minus P? Here, what is minus P? P is nothing but your class A, N is class B, positive and negative, right? So I can write it down as minus 5 by 10 log 5 by 10. 5 by 10 is how much? 1 by 2, okay? Minus 5 by 10 log 1 by 2. So this is minus half log 1 by 2 minus half log 1 by 2. So this is basically minus 1 log 1 by 2. Okay, log 1 by 2 is nothing but minus 1. Okay, so minus 1 multiplied with minus 1 is going to be plus 1. So that is my entropy of my class attribute. Going back to the comment section. किधर गया comments? Yeah, nothing. So entropy of class attribute is 1. Okay, now what I need to do is we need to divide the data. Again, same thing: age, how many old, how many mid, how many new. So here, profit, how much profit do we have? Profit is 0 and down is 3. Profit is 3, down is 0, and here this is 2 and 2, right? So if I draw a simple table, let's say old, mid, and new. This is my profit and this is my down, up and down. Okay. Old, how many ups? Zero ups, three downs. Mid, two ups, two downs. New, three ups, zero downs. So here you need to calculate information gain. Okay. Now what is the formula of information gain? I'm doing individually. Okay. For the first one, the information gain formula is, you will have to take the same formula. So minus p, which is minus 2 by 4 log base 2, 2 by 4 minus 2 by 4. Okay, I'm doing for the second record. Sorry, my bad. For the first record, it will be minus 0 by 3 log 0 by 3 minus 3 by 3 log base 2, 3 by 3. Now this is 0. This is minus 1 multiplied with log base 2 of 1. This is nothing but 0. So the information gain here is 0. So either of these record is 0, your information gain will be 0. What will be the information gain for this record? It will be minus 2 by 4 log base 2, 2 by 4 minus 2 by 4 log base 2, 2 by 4. This will be minus 4 by 4 log base 2, 2 by 4, which will be minus 1 multiplied with minus 1, which will be 1. Okay. So here my information gain will be 1. So this is my information gain for age. Now, after information gain, you have to calculate the entropy of age. The formula of entropy of age is summation of pi plus ni divided by p plus n multiplied with information gain. So for the old records, it will be 0 plus 3 divided by 10 multiplied with 0 plus 2 plus 2 by 10 multiplied with 1 plus 3 plus 0 by 10 multiplied with 0. Cancel, cancel. 4 by 10 is 0.4. Till now, did you understand? If not, I will repeat. Slowly, slowly, if you grasp, you will understand. First, what I have done is I have calculated the entropy of the class attribute overall. So you have 5 down and 5 up. That's why your total entropy is 1. Then I divided the data into different features. I am analyzing only the age column right now. So for age, this is my table, distribution table. From there, I am calculating the information gain. So individual information gain is 0, 1 and 0. And then you have to follow this formula. Okay. So if you follow this formula, the final output is 0.4. Similarly, I will take the next one, which is competition. Competition also, I will do a small table. Profit, loss, and let's say I will also write down information gain. Here, how many profit records do we have? Yes and no, right? So simple, we have two things, yes and no. So for yes, how many up? Down, 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 one up, three down, one up, three down. And here it will be for no, down, down, up, 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 up. So 4 up and 2 down. Okay. So what will be the information gain of yes? The information gain of yes will be minus 1 by 4 log 1 by 4 minus 3 by 4 log 3 by 4. So what will be, one second. So here, sorry, log 1 by 4 is log 0.25, 0.25. So the value is minus 2. Okay. So this is minus 1 by 4 multiplied with minus 2, uh, minus 3 by 4 multiplied with 75 is minus 0.415, minus 0.415. So what will be the final value? The final value will be 1 by 2 plus, let me calculate, 0.75 multiplied with 0.415 is 0.31, plus 0.5 is 0.81. So total will be 0.81. So I will write it down as 0.8. Okay. Similarly for this one, minus 4 by 6 log 4 by 6 minus 2 by 6 log 2 by 6. So what is log 4 by 6? Log 4 by 6 is 2 by 3, which is 0.66, which is minus zero point 0.6. So minus zero point 0.6 minus 2 by 6 into log 0.33. 1.6 minus 1.6 minus 1.6. What will be the total value? If I calculate 4 divided by 6 multiplied with zero point 0.6, 0.4. 0.4 plus 0.4 is 0.93. So I will write it down as 0.9. Okay. So my Ig is calculated. Now I will again use this formula to calculate the entropy of competition. So summation of Pi plus Ni by P plus N multiplied with Ig. Many people are not liking mathematics, so people have dropped the class. Anyways, summation of Pi plus Ni, which is going to be 1 plus 3 by 10 multiplied with zero point 0.8 plus 4 plus 2 by 10 multiplied with zero point 0.9. So total will be 4 by 10 0.4.32 plus 6 by 10 0.6.54, which will be 0.86. Now competition, age, entropy of age is zero point 0.4, entropy of competition is it's going to be 0.86. Okay. Now this is not the final final values. Now there is another formula that I have not introduced. Okay. The formula is the information gain formula. I'm not doing it for type. Okay. For type you have to repeat the same thing. Okay. So if you remember, the entropy of class attribute was 1. Okay, 1. So entropy of class attribute was 1. Entropy of age was zero point 0.5. Entropy of competition was 0.86. Okay, important formula is here. The gain, which is called as information gain, which is nothing but entropy of class attribute minus the entropy of individual features. So for age, what will be the final gain? The final gain is 1 minus zero point 0.4, which is 0.6. And for competition, the final gain is 1 minus 0.86, which is 0.14. Now, which is bigger? This is bigger. So, age becomes my top root node. And similarly, you have to calculate for type. Understood the entropy technique, or do you still have doubts? Okay, if you still have doubts, you can go through the video once again. You will get the clarification. Okay, mathematics is done. We will jump into the next topic, uh, which is going to be the practicals. Again, this Miro board will be shared to you. Again, I have not shared this, right? I'll quickly share it um, in the video description, but after this class I cannot go and do that right now. So I'm coming back to my practicals. Here we were building some models, right? Now I will write it down as KNN. Okay, we will do another model building for decision tree classifier. So I will write it down as DT. Okay, code I will just copy paste as of now. Y prediction, and then everything is done, and then accuracy done. Okay, now entropy is different approach of calculation for, yeah, and entropy and Gini are two different ways of calculation. Whether Gini is good or entropy is good, we don't know. We have to perform hyperparameter optimization to check whether Gini is best or entropy is best. But both of them are mathematical techniques and both of them are different. Okay, your model results will be different when you are using Gini and when you are using entropy. They both are completely different. Okay, now coming back to the model building part. Here again, take help of Google. Just search sklearn decision tree. You will be redirected to the documentation. Copy this path, sklearn.tree, import decision tree classifier, done. And then call this, I will change this to DT. That's it. My decision tree classifier is ready. Now I will rename this to DT, and I will rename this to DT, and then I will run the model prediction, and then in the accuracy I will call my ypred DT, and then I will check my accuracy. Oops, my accuracy is gone down. KNN was giving me better results. So decision tree is not giving me better results, but it's completely fine. Okay, predicting for a new patient, I'm not repeating. You can just, instead of model underscore KNN, just call model underscore DT, and you're good. Okay, so that's all about your decision tree classifier. The next algorithm that we want to discuss is going to be random forest. There are many other algorithms. We'll have to skip some of them because covering each and everything will be difficult. Random forest. Okay, random forest uses multiple learning algorithms to obtain a better predictive performance. Now, before talking about random forest is basically a um, some sort of a ensemble learning technique. It's a hybrid technique. So maybe we will cover it in depth later, but for now I'll just give you basic understanding on random forest. Okay, the classic interview question when it comes to random forest, and till date you go, many of your friends must be data scientists, right? Just go them and ask this question. I'm pretty much sure many of them will not be able to answer. I can bet my life many people don't know the answer. Why it is called as forest? That's very simple. What is a forest? Forest is nothing but a combination of trees. So if you combine multiple decision trees, that becomes a random forest. But what is random? What is the random part? That we will try to understand. Okay, there is no mathematics behind this, because eventually random forest uses decision trees, right? So there is no mathematical explanation to random forest. If you are good with decision trees, then you don't have to worry about random forest, because they are eventually combination of decision trees. Okay, but the most important thing here is this keyword. Why it is called random? That is the key point. Many interviewers ask this. Okay, focus. You have data, right? In your data, you have your y variable and you have your different x variables, right? Let's say there are 20 features. In our example itself, how many features are there? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Oh my god, that was a bad thing. Let's say there are 30 features, right? So we will also go back to this one and we will write down there are 30 features. Okay. Same thing, you divide the data into training and test, right? So this is your training data, this is your testing data. Now random forest, before random forest, let me just toss you a topic called as ensemble learning. Ensemble learning is nothing but a hybrid learning. There are two parts of it. One of them is called as bagging, one of them is called as boosting. Again, in depth, I will cover it in another class, not today. Random forest is a bagging technique. Okay, bagging means it basically creates different bags. So let's say bag 1, bag 2, bag 3, bag 4, dot, bag n. So I will write it down as bag 1, let's say decision tree 1, decision tree 2, decision tree 3, decision tree 4, and decision tree n. Okay, I'm rubbing this off. Now, what is the randomness here? When you are passing the data to these individual decision trees, there are two things that goes to these decision trees randomly. First of all, imagine you have 1000 records, okay, and imagine your testing training data you have 800, testing data you have 200. First of all, when you are distributing the data to your individual decision trees, there are two things that are random. One is random data, and second is random features. Okay, that means maybe out of these 800, 200 records and 5 features are going into this. Here, let's say 100 records and 6 features are going into this. Here, let's say 500 records and 16 features are going into this, and the process goes on. So data can be repeated, repetitions are allowed. That means our data that is present here can also be present here, can also be present here, no problem. Okay, so data is random and features are random. Now the advantage of this process is, see, out of this data, out of these 30 features, there could be potentially one feature that could be important, but you are not able to identify its importance. So when that feature goes into a particular decision tree, that decision tree understands that feature very well. So imagine this way, you are studying for exam, right? Now if you learn chunk by chunk, okay, I'll give you a very basic scenario. There is an exam, you have your unit test. Monday test in your college. Okay, teacher has allowed you to cheat. Just giving an hypothetical example. Okay, teacher has given you to cheat. They have allowed you. So there are 5 chapters. There are 10 people. Obviously 10 people will be studying, like one person will study half a chapter, another person will study few pages, another person will study few pages, right? And then you combine together, and then you will be able to share your knowledge, right? That is the power of random forest. Small decision trees combined together become a powerhouse. Cheating was a bad example, but it came to my mind, so sorry for that. So what happens here is, each and every decision tree is a small trees with simple features, less features. Okay, so you can treat them as small plants, small leaves. Okay, after that, what happens is, you have to pass the testing data. Now on your testing data, this predicts, this predicts, this predicts, this predicts, everybody predicts. And on top of that prediction, you take a voting. That This entire process makes random forest a better model as compared to decision trees. Mathematically, everything remains the same based on how you divide the data. Based on that, in random forest also, if you go to the sklearn random forest classifier, here also there will be a criterion. There is criterion because internally all your trees should follow a technique, whether Gini or entropy. And this is the most important parameter, which is the number of trees. So if you define 100, that means 100 trees are defined. Okay, how voting happens? For example, out of this testing record, right? For the first record, let's say this decision tree has told you that the patient is cancerous, cancerous, non-cancerous, cancerous, and based on voting, majority voting is cancerous, so your final output is cancerous. That is how voting happens internally. Okay, so this n is defined based on this n estimators. Again, what is the right value? We don't know. Hyperparameter optimization will help you to identify the right sweet spot. Coming back to the coding is, we will be implementing random forest. So let's say I will implement random forest. Again, I will copy paste these codes, 3 codes. Okay, so random forest is present inside ensemble. So here it is random forest classifier, and then call this classifier, change it to rf, model rf.fit, done. And then here change it to rf, change it to rf, done. And then change it to rf, and done. So it was expected random forest will definitely give better results than decision trees in 99% cases. In certain cases decision tree could be better, but most likely random forest gives better. Okay, but knn is still our topmost. So if I go back to my original architecture, right, I hope you're able to get an understanding that yesterday we were explaining you the architecture, right? ml1, ml2, ml3. So this is what it is. First one was knn, and then decision tree, and then random forest. Till now knn is giving me the best results. So now if I have to take the decision, I will take knn, go for hyperparameter optimization and improve the score. Okay, but yeah, we will be covering hyperparameter optimization. So Let me just give me 2 minutes. Let me think how are we going to cover the rest of the classes, because I only have 3 weekends for ML. Um, After that, I'll not be. Wait. This weekend, and after that, I'm not available for 2 weekends. I'll not be available. So, if we have completed 4 hours, uh, because based on that, I will be able to explain the next algorithms. So 4 hours is complete, right? And then we potentially have 8 hours. So tomorrow, if I go for regression, next 6 hours, I have time series for 2 hours, hyperparameter optimization project. Hmm. Clustering is also there. So I think that's it. We will not be able to cover. Um, okay, let's cover one more algorithm. Okay, naive Bayes and support vector. I will just give you a brief idea how it happens. Um, Logistic regression, I will try to explain you in the regression part, because once your regression understanding is done, you will be able to understand logistic regression. So let's go for naive Bayes algorithm. Unfortunately, 7 p.m. is not possible, Karthi. I wish I could, but um, not possible. 8 to 11 is still fine, but 11 will be like 1:30 for me. Let's see, I'll figure out something. Um, if we are short of classes, we'll see. Don't stress out a lot. For now, let's have 8 to 10. So naive Bayes classifiers are collection of classification algorithms based on Bayes theorem. It is not a single algorithm but a family of algorithms where all of them share a common principle, that is, every pair of features being classified is independent of each other. Okay. Um, Please like, share, and subscribe the channel, guys. Whoever has not done it, just a reminder for you all. Class files will be shared to you after the class is over, so nothing to worry about. So let's take this example and try to understand naive Bayes algorithm. Okay. Um, okay. Let's say I will take the screenshot to Miro board and I will explain it there itself. I'm actually in love with this tool. Um, all of my latest lectures are also taught on Miro board, and it's good, at least better than paintbrush. I usually teach using paintbrush, but now I'm using Miro and I'm happy. Okay. Um, okay. Now this is the example that I'm going to explain you. So naive Bayes classifier. Now this is based on the principle of Bayes theorem. Okay. So some sort of probability knowledge will be important. Bayes theorem is covered in my statistics class. Those who have not gone through my statistics videos, go to my channel. There is a playlist on business statistics. Watch out these videos. You will be able to understand the uh, minute concepts about Bayes theorem and conditional probability and all those things. Okay. Bayes theorem. What is Bayes theorem? Bayes theorem is simply based on the principles of this. Probability of A given B is true is nothing but probability of B given A is true multiplied with probability of A divided by probability of B. Understand this way. Naive Bayes algorithm is that kind of algorithm where it treats every feature individually. Okay. Every feature is individual and independent of each other. And this is your y variable. You want to predict whether a person under these conditions, overcast, cool, and let's say normal, weak, whether this person will play or not play. That is my question, right? That we need to solve using knife based algorithm. So the first thing is, what is the probability of playing? Can somebody write it down in the chat box? And what is the probability of not playing? There are six cases here, okay? What is the probability of playing and probability of not playing? The probability of playing is yes, 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 3 by 6, which is 0.5. The probability of not playing is 3 by 6, which is 0.5. You are able to hear my voice, right? Nobody is responding. Yeah, good. Thanks. Right? Probability of both is zero point 0.5 and zero point 0.5. Now, what I'm going to do is I'm going to take feature by feature. So, I'm going to take feature 1 here, which is day. We have sunny, we have overcast, and we have rainy. Inside sunny, how many times the person is playing, how many times the person is not playing? The person is playing 0, not playing 2, right? In overcast conditions, how many times playing, how many times not playing? In overcast, playing once, not playing once. In rainy, playing and not playing, playing 2, not playing 0, right? So here we need to find what is the probability of sunny given that the person is playing. So this basically means what is the probability that it is a sunny day given that the person is playing. It is difficult to understand, but try to understand this way. How many instances the person is playing? There are three instances the person is playing, right? So the denominator will be 3 and the numerator will be 0, which will be 0. What is the probability of sunny given n is true that the person is not playing? So here the person is not playing will be 2 by 3. Got it? Similarly, person overcast yes will be 1 by 3. Same will be overcast no. For rainy yes, it will be 2 by 3. For probability of rainy no will be 0 by 3, which will be 0. All these things are clear to you? Clear? I will go for temperature. If it is not clear, pay attention to temperature. I think it will be clear. Hot, mild, and cool. How many yes, how many no, how many yes, how many no, how many yes, how many no? Hot, 3 hots. So playing yes, not playing 2. Mild is 1, playing yes, not playing 0. Cool is yes, yes, playing 1, not playing 1. Okay. So what is the probability of the temperature is hot given the person is playing is 1 by 3. What is the probability of hot given the person is not playing is 2 by 3. What is the probability of the weather is hot mild given the person is playing? 1 by 3. What is the probability of mild given n is true is 0. What is the probability of cool given y is true is 1 by 3. Cool given n is true is 1 by 3. Okay. Similarly, you have to do it for wind and humidity. So let's say quickly I will do it for humidity. How many options do we have? We have high and normal. How many yes, how many no? How many yes, how many no? High we have 3, sorry 4. So 2 yes, 2 no. 2 yes, 2 no. Normal will be 1 yes, 1 no. Right? Probability of h given y is true is 2 by 3. Same with probability of h given n is true. Probability of humidity is normal given y is true is 1 by 3, which is same as n by n. Okay. Lastly, I'm taking wind. I'm doing wind here. Okay. Weak and strong. How many yes? How many no? How many yes? How many no? So weak, 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 weak. 3 yes and 1 no. 3 yes, 1 no. Strong, strong. 0 yes, 2 no. Okay. So what is the probability of the wind is weak given the person is playing is 3 by 3, which is 1. Windy given the person is not playing is 1 by 3. There is a strong wind given the person is playing is 0. Strong wind person is not playing is 2 by 3. So individually you have got all the probabilities. Now the question is simple: overcast, cool, normal, and weak, right? So you need to find probability of overcast, cool, normal, and weak given y. So this will be probability of y multiplied with probability of overcast given y is true. There are 7. What is 7? 1, 2, 3, 4, 5, 6. This is the question. The seventh record is the question. There are 6 records. This is the question that we need to solve. Okay, so we need to find, given this condition, overcast, cool, normal, and weak, what is the probability of playing. So the formula is this: probability of cy multiplied probability of ny, probability of y. What is the probability of y? It is 1 by 2. What is the probability of um, overcast and playing? Overcast and playing is 1 by 3. What is the probability of cool and playing? Is 1 by 3. What is the probability of normal and playing? Normal and playing is 1 by 3. What is the probability of weak and playing? Is 1, which becomes 1 by 54. Okay. Similarly, you have to find the probability of overcast C and W with respect to n. This formula is probability of n multiplied with O over n multiplied with C over n multiplied with n over n multiplied with weak over n. So this is 1 by 2. Overcast over n is here. Overcast over n is 1 by 3. So 1 by 3. C over n, cool over n is 1 by 3. So it is 1 by 3. N over n, n over n is here 1 by 3, which is 1 by 3. Weak over n is 1 by 3. This is 1 by 3. So this becomes 1 divided by 162. I'm done almost. And then you can ask. So if you go and calculate these numbers, let's use calculator. 1 by 54 is 0.018, 0.018, and uh, 1 by 162 is 0.006. So don't look at the magnitude. The simple question here is which number is bigger. That's it. and you can see this is a bigger number. So the output here is going to be the person is going to play. Under this condition, this person is going to play as per naive Bayes algorithm. Now you are able to understand, right? What exactly is naive Bayes algorithm? So if I go back to the codes, see again, coding is not that difficult. So I will quickly run through the naive Bayes classifier. So I'll just copy paste these codes, and then again I'll search sklearn naive Bayes. So here you will be able to get, there are multiple naive Bayes algorithms, Gaussian, um, categorical, multinomial. Will try to go for Gaussian. From this Gaussian NB, from this I'll go for Gaussian NB, and then I'll call this NB, NB, run this code, and then NB, NB, run this code, and then I will run this one and see whether my naive Bayes is giving me good results. My naive Bayes is giving me 94.41, which is not bad. Same like random forest. Okay, not bad. So this is how you work on different algorithms. Now, the last algorithm that we will talk about is support vector. Now, support vector basically works on the principle of, it's not possible to finish. Maybe we'll cover it in the next class. Okay. So there are some pending items which we were not able to complete today. So next class we are going to plan this way. The agenda of the next class, let me just explain you. So accordingly you can decide whether you are going to join that or not. So next class we will be covering SVM, mathematics and everything. We will be going for classification metrics, and then we will jump into regression. Okay. um, Regression with practicals. All of these three topics will be covered in the next Saturday. And going forward, next to next Saturday, we'll go for clustering and then time series forecasting and various other things. So that brings to an end to this particular session. Thank you all for joining in part 2. Now I'm completely open for questions. In case you have any questions, you can ask me. Just a disclaimer before you ask, I'll be very honest with you. My channel already has multiple things. In case you are confused, what to go, what to learn, and all those things, everything is here. See, business statistics is here. Almost 6 hours of videos on statistics. If you go for Python, we have Python. Somewhere it will be here. Python end to end is here. These are not Python end to end. These are Python uh, projects. Python bhi hai. Python. Yeah, Python. Python is there. End to end Python is there. Almost 6-7 hours of videos. End to end EDA is there. If you just search EDA Satyajit, you will get my video. 6 hours of content on EDA. 5 hours of content. Okay. So EDA is there, Python is there, SQL is also there. You can see we took a live class long back, almost 6 hours of content on SQL. So everything is here already. But in case you are in need of a dedicated program, as I told you in the last class also, I have an end-to-end program on data analytics, data science, and AI. It's like a complete package of everything. You will find a bunch of topics here, and after this you need not have to worry about anything. Everything is covered in this program. Okay, starting from Python, statistics, SQL, machine learning, NLP, deep learning, transformers, generative AI, and various other things. In case you are interested to enroll for this course, feel free to reach me out. I can onboard you at a discounted price. Officially, I'm giving it at 7,999, but if you want more discounts, maybe 1,000 more, I can give. Anything beyond that will be not good for me, because I do a lot of one-to-one sessions here, resume preparations, and all those things. So a lot of efforts are there. So it's not worth it if I sell this course at 5,000 or less than that. So the lowest will be 6,999 is what I can offer you. Everything is there. End-to-end projects are there. If you want to check out the projects, I can show one of the projects. Documentation is also provided. Detailed documentation is provided in each and every project. So you will learn a lot. You will get lot of, you know, exposure on topics and then projects. Anyways, I'm looking at the comment section. Okay. Comments. So can you tell me which situation? Uh, one second. Let me remove my recording. Okay. Okay. Now the question is, sir, can you tell me? Let me read it. Can you tell in which situation we use which algorithm? The way I explained you, right? We have to try different algorithms, KNN, then decision tree, random forest. Same in any kind of industry level problem, we try with different algorithms and then choose one of them and then go ahead and do the hyperparameter optimization. Okay, it's a nice. Thank you. As I mentioned, the question, what should I have to learn to become a data analyst? Okay, good question. Follow this link. My bad. Follow this link in the comments, or maybe I'll maybe you can reach out to me on WhatsApp. I will leave you this link. Um, you will be able to get a detailed curriculum syllabus of data analytics, so you can follow that. Python, SQL, statistics, Excel, Power BI or Tableau, predictive analytics, ETL basics. These all things are needed to become a data analyst. And then portfolio projects. Code is shared with us. Yes, I have given you the GitHub link in the description, but I will be updating the code, and I will share with you the latest code after the class is over. Okay. I have learned skills like Power BI, Python, Stats, SQL. Should I learn any more skills for? No, anything else is not needed. Just go for some basic ETL videos. Just learn some data engineering concepts, little bit. Data warehouse क्या होता है, data lakes क्या होता है, data marts क्या होता है. Just go through these topics and you are good. SQL, focus more on SQL. Okay. So there are too many formulas. How can I memorize them all? Give some insights regarding this. See, what I do is the moment I start learning, right? Like I usually, whatever I learn, I usually write them again and again and again. Now, this is not something that I have been doing recently. It's from my school days. Whenever I learn something, I write it down. Then what I do is, once my notes are already ready, I create another notes, and then whatever I'm memorizing, I write it down without looking at my copy, and in that process you will learn automatically. Other than that, there is no shortcut. Some things you need to learn: Euclidean distances, scaling algorithms, formula of standardization, variance. All these things you have to learn and memorize. Correlation, covariance, what is the formula, all these things, right? Yes, SQL and Python are essential. EDA, on the course is same as what is present, yeah, or what is present on YouTube. uh, exact same thing. uh, my EDA videos on YouTube channel is same. So from my entire curriculum, only the EDA part and the statistics part is exactly the same from my entire course. But anything else, I have not made public. All of my course contents are completely different. Like right now, I'm teaching machine learning, right? I'm aiming for 12 hours, but in my program, I have around 25 hours of machine learning, and then there are 10 hours of projects, and then 20 plus machine learning projects. So those contents I cannot upload it on YouTube completely for free, right? So but on YouTube I'm giving enough information for free. So people who don't want to invest, it's completely fine. You can just attend the YouTube videos, go through the playlists, and you're good. But if you want fast paced learning, jaldi jaldi learn karna hai, and you want some guidance from me, you want to ask doubts especially on your domain, because there could be customized doubts, right? In your journey you will get a lot of doubts. Only for those people who want some guidance, doubts, job assistance, and some sort of resume assistance, then you can take the program, else there is no need. So this is the link of my data analytics program. You can note it down and you can check it out later. Do you have generative AI full course starting from scratch? From scratch. I have generative AI course. Okay. I have videos on end to end NLP. Okay. When it comes to NLP, I can also give you the topics that I have. Everything. So in NLP, I have introduction to NLP. Then I have NLP basics, case folding, handling contractions, tokenization, stop word removals, n-grams, vectorization, word embeddings, bag of words, practicals, TF-IDFs, POS and NER practicals, and then word embeddings, word to vector, and various other word embeddings, cosine similarity, LSTMs, GRU, bidirectional LSTMs. When it comes to transformers, self attention, encoder architecture, contextual embeddings, decoder architecture, BERT architectures, Roberta, Distilbert, Albert, GPT architecture, multi-mask attention, GPT blocks, training, LLM basics, context window, RAGs, prompt engineering, uh, fine tuning, each and everything is there. And 6 projects. Right now I have 6, but I'm already working on 4 more. So 10 projects I have. And the projects that I have, I'll be very honest, I have sold those projects to clients. So those are actually real projects, real client based projects. Okay. I don't fool around with basic things. I have a project on insurance claim. I have a project on medical practitioner. Let's say you go for reports, you go for blood test, you get some reports, you can analyze your reports and talk to a chatbot like a general practitioner. There are OCR plus generative AI based projects also. There is a project where we have done a website scraping. Based on the scrape data we have created a chatbot. And all of my projects are Flask projects with beautiful functional UIs. Sorry for talking a lot about the course, but yeah. So thanks, because I am learning from open source. That's why I was confused. No problem. On website, Data Science AI Masters is showing me 99 and how to get the discount. Reach out to me. See, 9999 is the market rate. Whoever lands and pays directly, they do that. And I run some ads, not much, but so people who get through those ads they pay directly. For my YouTube audience, my regular viewers, people who know me, people who have my WhatsApp number, for them the prices are different. 7,999. For my existing data analytics students, I have given the same program at 5,000. So for you all, I can give it at 7,000, like 6,999. reach out to me on WhatsApp, or ping me on LinkedIn. I will give you the discount coupons. Okay. What visualization tool is best, Power BI or Tableau? See, I'm a fan of Power BI, and in my entire career, only for 6 months I have worked on Tableau. So you can see the acceptance level of Power BI is more, especially in the Asia Pacific area. Companies are working with Microsoft products, so Power BI is an important tool as compared to Tableau right now. Where to find the generative AI course? My AI program. You can reach out to me. I'll share you the syllabus. Data science AI masters. Is it includes generative AI? Yeah, that is the one. Yes. Do you need to learn DSA for machine learning or data science? See, in-depth data structure and algorithm is not needed. You don't have to be pro in coding. You don't need to solve very tough lead code, Python questions on lead code or hacker rank. Um Intermediate level is fine, because honestly, in the space of data science and AI, they usually don't. Sorry, I'm giving you my WhatsApp number. You can just send me a hi. Okay. So usually they don't ask you coding questions. Okay, right? Do a coding in front of me. They don't do that. So you are safe. In Python programming interviews, they will grind you on Python. But in data science or AI, very few companies will ask you Python programming questions. So you don't have to be a pro. Intermediate level is fine. But eventually, when you start working on end-to-end projects, you need to know more things, like how to, you know, convert a code into APIs, into Lambda functions. So these things you will automatically learn. So with due course of time, you will learn. So do not worry about it. Um, Last 2 minutes. Any other questions do we have? If not, we will close this class and we will catch up again next Saturday 8 p.m. Just 2 more minutes if you have any questions. Okay. In case you want to, how did you learn? That's a very good question. I can talk about my journey. I have actually never talked about my journey in depth. Um, if you want to listen, I can tell. But honestly, I was thinking about this last few days back. I was thinking about a video where I will talk about myself on how my journey was starting from beginning. But I don't know if people will be interested to know that or not, because the video will be too long. But yeah, my journey has been very simple. Um, I come from a very simple, lower middle class family. 10th and 12th, luckily I was studying in CBSE in Odisha. My father, um, when I was like when I started my schooling, my father's salary was 400 rupees. So he has done a lot of struggle, but still he was successful in putting me into an English medium school. So my entire schooling has been into DAV, and then I joined BTech in one of the local colleges in Odisha. And in fact, I got the maximum offers from my college. I got four offers, and from there I joined one company called as Amdocs. It's a Pune based company. I mean, the office is in Pune. It's a Israel based company. Um, so I started working as a Java developer in 2011. So almost it's been more than 13 years I'm working in this industry. From Java developer, actually, in 2016 I was trying to jump into Bangalore for a job, because 2016 I married. My wife was in Bangalore, I was in Pune. and then I had to switch to Bangalore, and then I was applying for jobs. That is when I was actually offended by an HR. I applied for a job in Morgan Stanley. They basically asked me about Java and machine learning, and I told them I don't know machine learning. I thought machine learning is something like related to mechanical engineering. I'll be very honest, I did not knew machine learning is AI back then in 2016. And then I was offended by the HR that it's 2016, people are going crazy about AI and machine learning. You don't know what is machine learning. I felt so offended, and then I came back and then I searched, and then I realized, oh shit, machine learning is AI. I know about it, but I did not know the term machine learning. The term was new to me. And then 2016 I started grinding. I took a program, 35,000 INR. I took that program. I honestly speaking, I have never gone through that program, not even 15 minutes. I have never watched the videos. I still have that program with me. Um, Everything is self learning for me. I started learning through different sources, started accumulating syllabuses from different edutechs. In fact, from the company that I had joined the course, I had the syllabus. From those syllabus, I started doing my research. I was fascinated with time series forecasting, so I did my first research into time series, and then I got a job in British Telecom in 2017, where the job profile was a data scientist, and then they were expecting somebody to have programming knowledge and on top of that machine learning. But I was very honest with them. I don't have machine learning knowledge hands on. I do have some analytical knowledge. I have worked on some dashboards, but I did not had any machine learning knowledge. British Telecom was very very um, I would say my best 2 years of my entire career was in British Telecom, because when I joined, my manager was so good. He basically gave me 3 months to just study machine learning and deep learning. He told, we don't want anything from you, just study, because we have some use cases in mind. We want to develop that, so study. So I was studying into time series forecasting analysis, into ensemble learning, into recommendation engines, and then I started working on practicals, and then that's how my journey started. And 2019 I applied for more than 5,000 jobs, and then got into Hong Kong. And in Hong Kong, um, life has been going good. Things here are fine. In 5 years, I have already changed 5 companies, but that's how it is in Hong Kong. Mostly the jobs are contractual jobs, so your 12 months or 18 months is over, you change your job. As simple as that. So that's how it is. That's it, guys. It's too late for me. Almost 1 o'clock in the night. Thank you all for joining in. It was a pleasure. Um, Going for this part 2. Part 3, we will be catching up same time, Saturday and Sunday, 8 p.m. IST. Please tune in. Do not forget, I will be creating the live video. Go and like the video so that, and notify, click on the notify button so that you are notified when I go live. As simple as that. See you next class. By the time you join the next class, please do a rehearsal on part 1 and part 2 before you jump into the part 3 lecture. See you. Bye bye. Yeah, please, Yash, please ask. I'm still there. uh yeah, please ask. Oh, you already have a question. Sorry, my bad. I'm doing an internship right now, which I got off campus. I am doing an internship. Okay, my CGPA is low, so I won't be eligible for an on-campus placement. How tough will it be to get an off-campus placement for C++ developer role? See, getting a job is difficult, right? It was difficult in my time. It is difficult in now also, but it's not a big deal, because as I told you, I got 4 offers, but I joined the company which I cracked through in an off campus placement. On campus I got 3 offers, but amdocs I cleared off campus. So you just have to try it out. So it's not that a big deal. On top of your C++ backend development role, if you can, please mention some front end technologies as well, because you will get more opportunities if you have a full stack developer role, right? As compared to a backend one. Yes, I do have a Udemy. Just search Udemy and my name, you will get my profile. uh, Udemy and Satyajit Pattnaik. If you search, you will be getting my profile. Under that, you can check out my courses. But again, I don't have a lot of courses on Udemy, because honestly speaking, Udemy has a very bad dynamic pricing. Even if I fix the pricing to be $100, for sometimes I get $5. So there has been cases where people enroll for my program and I get $5. Sometimes I get $4. So you imagine $5 is nothing, right? $5 is 300 Indian rupees for one entire course. And then people join it in 300 rupees, and then if they don't like something, they will give you 1 star rating. That's why I I don't want to get into Udemy. It's very, very difficult. Rather, I have created my own platform on Zep Analytics, where I have much more contents and I provide one-to-one guidance and support as well. That's it, guys. Enough for today. Thank you all for joining in. See you next class. Till then, bye bye.